I'm Jamariya Howard, and I work on FR20 NADP oxidoreductase, found in methanogenic organisms and sulfate-reducing archaea. There are currently very few studies out there about FNO, and this poster will provide you with a detailed mechanistic study about FNO and also provide you with a kinetic model displaying a change in cooperativity. This is the FNO crystal structure, so if I were to take this and split it down the middle, you would see two identical subunits. To the right is an expanded view of the active site, which contain one FR20 molecule and one NADP molecule, which is about 3 angstroms apart from one another, which is an acceptable distance for hydride transfer to occur. This is the structure of the F420 cofactor. The F420 cofactor shows a large absorbance at 420 nanometers, and upon reduction, it loses that absorbance and gains the shoulder at 320 nanometers. FNO catalyzes the reversible reduction of NADP to NADPH. The hydride is transferred from the reduced cofactor over to the fourth position on NADP, producing NADPH and oxidized cofactor. Two previous researchers in our lab work with the FNO form of the enzyme. They took the steady state data that they had and fit it to a double reciprocal plot. With a double reciprocal plot, if you see something that's downward and concave, like you see here, it's an indication of negative cooperativity. If you see a straight line, that indicates no cooperativity. And if you see something that's upward and concave, that indicates positive cooperativity. They took it a step further and did pre-steady state experiments for wild type. And they see that the trace that you see here, which is a fast phase and a slow phase, indicating that they see biphasic kinetics, indicating biphasic kinetics and half-side reactivity, indicating that they've seen one subunit communicating. They've seen these subunits communicating with each other, but with negative cooperativity, it is an indication of one subunit working at a time. And this is where my work comes in with the inter subunit interface. In the interface, we decided to create a library of mutations that you see here. With these mutations, we decided to do binding studies first. So compared to wild type showed the kinetic parameters of 3.6 and 2.0 for FO and NADPH, indicating tight binding. They also took it a step further and fit the data to a Hill coefficient. For the Hill coefficient, if you have a number that's less than 1, that indicates negative cooperativity. If you have a number that's equal to 1, that means no cooperativity. And if you have a number that is greater than 1, that indicates positive cooperativity. So with wild type, they actually see negative cooperativity. But what was most interesting is what we've seen with these variants. With the variants, we managed to see a change in cooperativity for all the variants with the exception of T192A and the two H133 variants. These still show negative cooperativity like previously seen with wild type, but all of the other variants now display no cooperativity kinetics. In the steady state, we actually took this data for the NADPH and we fit them to a double reciprocal plot. For the double reciprocal plots, we actually seen that all of the variants now show no cooperativity kinetics, with the exception of T192A, which still shows a downward and concave curvature, indicating that we see negative cooperativity kinetics. But we also took it a step further and did pre-steady state. With the pre-steady state, we no longer see this biphasic kinetics like we've seen with wild type. We no longer see biphasic kinetics or half-side reactivity, indicating that we have managed to change the cooperativity from negative to no cooperativity kinetics. So to conclude, for the binding, the only variants that still show negative cooperativity, like we previously seen with wild type, are T192A, H133A, and H133N. Those are the variants that still show negative cooperativity kinetics, but all of the other variants now display no cooperativity kinetics. For the steady state, we actually seen that with the double reciprocal plots, we seen with the double reciprocal plots that most of the variants except for T192A now display no cooperativity kinetics, but T192A still shows that downward and concave curvature, indicating what we see for wild type. For the pre-steady state, the hydride transfer step for FNO was significantly slower than wild type, which suggests that these are important in catalysis, indicating that we did manage to change the cooperativity of FNO from negative to no cooperativity. Thank you.